You ever just look up at the night sky and get hit with that huge question, how does all of this end? I don't mean just our planet or even our sun, but everything. All the stars, all the galaxies, the whole shebang. Well, let's take a journey together, all the way to the end of time, to see what that final moment of our universe might look like.
I mean, it's the ultimate question, right? And look, while we can't know for sure, physics gives us this incredible and frankly mind-bending roadmap of what's probably coming. This is the story of the universe's final sunset.
Okay, so our story actually starts somewhere pretty familiar. But here's the catch. Cosmically speaking, this chapter is already wrapping up. We're living in the age of stars, but believe it or not, it is not going to last forever.
Think about it. Right now, our universe is just ablaze with light. New stars are being born all over the place, pumping out heat, energy, all this stuff needed for life. But this amazing time, they call it the Stelliferous era, it's really just a tiny, brilliant spark before, well, an eternity of encroaching darkness.
And the timescales we're talking about here, they're just insane. In about 1 trillion years, stars like our sun are all gone. But the real lights-out moment, that comes way, way later. We're talking 100 trillion years from now, when the very last little red dwarf star finally, poof, goes dark. And after that, nothing. Just a deep, profound, starless quiet.
So what happens then, when all the lights go out? Well, the universe doesn't just vanish. Nope, it transforms. It morphs into something new, a whole new and much, much darker era.
And this is the big switch. See our universe today? It's like this busy, buzzing workshop, right? Constantly making new stuff. But the future universe, the one they call the degenerate era, it's more like a cosmic graveyard. It's cold, it's dark, and the only things left are the ghosts of the stars that used to be.
So who's living in this graveyard? You're looking at them, the stellar corpses. You've got your white dwarfs, those are the leftovers of sun-like stars. You've got neutron stars, the super dense cores of giant stars. And of course, you've got black holes, the absolute champions of gravity. They're all just wandering through this cold, empty void, maybe with a few rogue planets that got kicked out of their long-dead solar systems.
Okay, and here's where it gets really, really weird. We tend to think that matter, stuff, is permanent. But some theories say, not so fast. Over these just unbelievable timescales, even the protons that make up atoms might not be stable. They might just decay. Imagine that. The very fabric of these dead stars slowly, atom by atom, just dissolving away into nothing but energy. So you fast forward trillions and trillions of years. Matter itself has pretty much given up the ghost. What's left standing? Just these guys, the cosmic titans, the black holes. They're the last holdouts in a universe that's completely unraveled. But even their time is limited. And that brings us to the final act. The absolute grand finale of the universe. The very last organized things have to meet their end. And how does it happen? Well, it all goes back to an incredible discovery by the one and only Stephen Hawking. So here's the crucial insight, and it's a big one. Black holes aren't actually completely black. Thanks to quantum physics, right at their edge, the event horizon, these little pairs of virtual particles pop into existence. Every now and then, one falls in, but the other one escapes. And when it does, it steals a teeny tiny piece of the black hole's energy. They basically leak. Now, this is an impossibly slow process, but it is relentless. So over eons and eons, they lose mass, they shrink, and then poof, they evaporate in a final flash of light. But okay, how long does this take? I mean, the supermassive black holes in the middle of galaxies are the biggest, most stable things out there. Their evaporation is not going to be quick. We're talking about a length of time that makes the 100 trillion years for the last star to die look like the blink of an eye. This is the number of years we're talking about. 10 to the 100th power. That's a 1 with 100 zeros after it. I mean, just try to wrap your head around that. It's a number so ridiculously huge, it actually has a name. Yeah, a Google years. To give you some kind of perspective, which is almost impossible, that number is way, way bigger than all the atoms in the entire observable universe. It's a timescale that our brains just aren't built to understand. And that's how long the very last black hole gets to stick around. So after a Google years, the last little flash from the last evaporating black hole finally fades away. And what's left? Absolute total and final nothing. We've reached the era of heat death. So what is heat death? It's basically the universe's final state of rest. It's the ultimate victory of entropy. You know, that rule that says everything always goes from order to disorder? It's like, imagine you have a hot coffee in a cold room. The heat doesn't stay in the cup, right? It spreads out until the coffee and the room are the exact same lukewarm temperature. Now just apply that idea to the entire universe. All the energy spreads out perfectly evenly. No hot spots, no cold spots, which means nothing can happen. No movement, no life, no change. Ever again. The universe becomes this almost perfect vacuum. Just a vast, empty void. The only things left will be a thin, cold soup of a few stray photons and subatomic particles separated by distances we can't even imagine. And since there's no heat, no energy being created anywhere, the temperature is going to drop and drop until it's just fractions of a degree above absolute zero. You literally can't get any colder than that. And that's the end of the line. Just a quiet, cold, unending darkness. The final sunset is complete. The whole story of our universe, with all its brilliant stars and galaxies, just comes to a silent, simple close. But it does leave you with one last tantalizing thought. In an eternity of perfect silence, what if a single random quantum fluctuation was enough to kick off a whole new Big Bang? What if the end of our universe isn't really the end at all, but just the quiet before the next cosmic dawn? It's a pretty humbling question to think about, isn't it?